My name is Lukas Lehmann. I'm working for Swisscom since 3.5 years now. I'm running the services team there for our Swisscom application cloud. That's our platform as a service offering. And I have a background in software development and system engineering. And I'm part of an awesome team that helped me and us building that next generation platform to run these cloud native applications. Through the next 30 minutes, we will cover the following topics. I will give you a short introduction what Swisscom is and how our database as a service offering looks in detail for our platform as a service, which challenges we face there, and how we could enhance that in the future. So what possible solutions are there around also Kubernetes or CoreOS, and lessons learned, how we could do things better next time. So what is Swisscom? As the name already has it in it, we are a telco provider. So we are actually the biggest telco provider in Switzerland. But we are also an IT services provider. So for example, for the banks, 60% of the Swiss banks are using our products to run their business. We have fixed network, mobile network, and we have a little bit more than 20,000 employees and about 12 billion revenue. So as you can see, we cover the whole cycle of serving residential customers, meaning via TV, via broadband, internet, via mobile network, or also the telephone stuff. And our cloud offering, there we approach a really unified solution that we want to offer to our customers that are on one side all the internal developers, all the internal product that we develop. So we have a platform there, and also we are a service provider for enterprises as well as residential customers that want to use that platform. So we have there everything out of one hand is our approach. So we have infrastructure as a service as well as platform as a service coming from one platform or from one portal at least. And we really focus there on open standards. So we don't want to lock in our customers. And as all the other platforms also, the things are scalable and prices are mostly usage-based. What we are going to focus on the next, or during this presentation, is the platform as a service part, which is called Application Cloud within Swisscom. The whole thing is live since beginning October. So you can go to developer.swisscom.com, register there, and the first 3 months you will get $100 off for your bill. And how does the Swisscom Application Cloud stack look like from a high-level perspective? We use KVM virtualization. We are running Red Hat OpenStack on top. And for the platform itself, we use Cloud Foundry. We use the open source Cloud Foundry, and within there, Diego as scheduler. And for running all the services, so all the databases, which serve the Cloud Foundry applications with state, we use Flocker. We're going to cover that part. Because why do we need services in Cloud Foundry, and what are services in context of Cloud Foundry? We can see this via this picture. So the users want to push or to host their cloud-native applications, mostly their microservices applications within our platform as a service. So Cloud Foundry can handle really well all the 12-factor applications. If your app is 12-factor ready, that's the way to go. really had a good success with Cloud Foundry so far, also as we are using the open source version. But if you want to provide state to these applications, so meaning the databases or message queues or key value stores, then you have to look out for another solution, because right now there is not something on the market. Or we started this initiative for the services, especially 1.5 years ago, and out there was nothing on the market which we could just pick and host our different kind of services on. So what does the user want for services? What does this mean for him? He wants to have a wide choice. He wants to have MongoDB, Redis, RabbitMQ, Cassandra, all kind of things, because his fancy application needs that. It needs to be instant available and have also good performance. The security monitoring is always very important, so that he can really see what's going on in my database, and also that the database itself is secure and his data is isolated and protected from other customers that are using the same platform. And also he wants to have on-demand backup and restore capabilities. And as well, last but not least, he wants to have his service to be always up to date. Means that if a new MongoDB version comes out, automatically or on demand, he should be able to update his service, or we should be able to update his service in a usable time frame. And for us as a service provider, this brings a number of challenges. So first, we need a generic solution for different service types. So we need a solution to host all these MongoDB, Redis, and different service types with one platform. Containers were a great help there. Also the multi-tenancy effect. Not all the databases have such a good multi-tenancy feature functionality in it as, for example, MySQL. Redis, for example, has not at all a multi-tenancy functionality. The security and monitoring part. Always when you build a platform, the high availability, going first from an active standby to an active passive mode, and maybe in the future to an active, even to an active mode, that we can, even if data center completely goes down, support the proper uptime. And the scalability, which is obvious that we can run a real large number of services in our infrastructure. And all this brought us 1 year ago, when we did this evaluation and had various speech with different providers, to the following technology parts. So for the container parts, to have the really generic solution, we evaluated Docker, because it was the de facto standard and it is still the de facto standard, most adapted container product. For the orchestration part, we picked Flocker from Cluster HQ there, because they were at this time really the only one caring about stateful applications, caring about persistence in container. And for deployment, we use Puppet. That's a Swisscom thing. Within Swisscom, we have really great puppeteers, which do a good job. So that was the main reason for going with that, to automate everything and have good configuration management. And as also mentioned in the slide before, for the infrastructure as a service part, we use OpenStack. Let me show you the big picture, how this works from an end-to-end user perspective. When a user comes into our platform and creates a service, what then exactly happens? So via the portal or the Cloud Foundry CLI, he can create a service. This request goes then to Cloud Foundry runtime. And the component there kicks on the service broker. The service broker is from Cloud Foundry a specified API that you need to implement on your side, which the Cloud Foundry Cloud Controller then speaks to. So this service broker on our side then speaks to our service manager. That's an own-built component. We will cover the function of the service manager a little bit more. And the service manager itself then calls the Flocker API, so the Flocker control service, and writes in the config of the Flocker API, hey, spin me up that new container with, if the user has created a MongoDB service, for example, with the Docker MongoDB image, with so much RAM, so much CPU shares, and a volume that is of this size. And then, on the various Flocker nodes we have, Flocker will place it on, or we will place it on one of the nodes. Then the agent of this specific node will talk to the Flocker API, get the new configuration, and spin up the service. So spin up first talk to the Cinder API, to the OpenStack Cinder API, where we underneath use Scale.io as block storage. So it provisions then a Scale.io volume, and Flocker then attaches that to your VM and formats the file system properly, mounts the device, and if that has worked out fine, then it will start up the container and mount that volume into the container. This is the simple creation process of having a stateful container. But why having this would also mean, or this means that we per container have a single volume. We could also have, if we have 20 containers running on that VM, all these 20 containers have writing to one volume. For that, we evaluated properly, hey, what exactly is the performance difference? So you see here, the blue line with 10 Docker containers running on a VM, and each Docker container has its own volume, so meaning you have attached 10 block devices, or you have 10 MySQL Docker containers and one volume attached, and this volume then mounted in all to the containers. And we see that with many volumes, we got a better performance, which then also convinced us to really go with that approach. But all this, just having the container running is not enough. Somehow we need to be able to monitor that properly, and also to have a DNS resolution, because in Cloud Foundry, once you have created a service and binded the service, I will come to this process. The environment, this stuff is written in environment variables and cannot be changed. So we need to have a proper service discovery. For that, we have on all our Flocker nodes, or basically on all our VMs, you have console agents running, on which, with every service that we create, we will create a proper console check on this agent. And this agent then always checks, hey, is this service available? And via this ID then, we are able to resolve where the container is actually running right now. And this is also where our monitoring system, Orchard, kicks in. Orchard is an own-built monitoring system developed completely internally that uses mainly, in our case here, console events. So it can see, okay, there was a new service created, that service is currently starting up, okay, that service is now running, and we see on a nice dashboard which services are in in a healthy state, which are in a warning state, and which are in an error state. For example, if file system gets full or something like that. And it's not just the monitoring part. It's here also about health management. So Orchard is able, if now node 1 dies, Orchard detects, hey, all these services that are running, all these containers that are running now on this VM are in an error state. Something is wrong with this VM. Okay, we need to evacuate all the running stuff, or no more running stuff, from that VM to another healthy VM. Orchard will then trigger, via the service manager, a reprovision call, where we, again, would, via the Flocker API, say, hey, please take this container on this specific node out of the configuration and place it on a healthy node. So Flocker would then go, detach the volume, and attach it on a healthy node, bring up the container again. No. Yeah, bring up the container then again on Flocker node 2, and the service is up and running again, and through the console DNS resolution, it's available under the same host. How does the service broker function work in detail with Cloud Foundry? So also why we needed this console stuff. So if we create a service, this call goes to the cloud controller, from there to the service broker, as shown before, and then we would spin up at the end proper resource for that service, so a Docker container with a running MongoDB. And now in Cloud Foundry, the users have the ability to bind that service to their applications, so to their stateless applications, which would raise in this call, that in the bind service call, which also goes to the cloud controller, then to the service broker, and we would then obtain the connection data, which means we would go and create for him on this MongoDB a user and give him back this user data, and this user data gets then propagated into the environment variable of the stateless application. And to that, the app run here in this example that's now running on the Cloud Foundry side is able to look up his host via DNS lookup on our console server, and then access directly to the service. So that means if we now kill node 1 and restart the service on node 2, it would just go and do a new DNS lookup, and it's then able to connect again successfully to the service. As you see, it's a lot of own-built stuff around it. We have Orchard, we have the health management. It's working. It's a working product. We have it running in production. The customers are happy so far, but there are things to improve. So the health management could be faster. Also the scalability, we have some limitations. The current setup, and also the scheduling. As you see, the service manager does the whole scheduling for us, mostly in a random factor, and this could be replaced by a smart scheduling system like Kubernetes or other orchestration frameworks that are proven to be able to do that. And as mentioned before, the scalability, which is very important, where we have currently Flocker, which is limiting us in going to higher numbers. So in the future, this could be a possible solution or an aim we go for, that we, instead of having our own build stuff, having an orchestration framework like Kubernetes, with, for example, a Flocker plugin that provides all the state, replacing our own built stuff. It makes a lot of more sense from our point of view to use such an open source great tool, which is proven to have the ability to handle that, than further develop our own built thing that will also come to the same limitations and come to the same problems that Kubernetes also already has solved. This already brings me to the challenges we had and to our takeaway lessons learned. So yeah, lesson 1 was distributed systems are hard. You really need to understand them and understand what you're doing. I think everyone can imagine that. If you change something on part A and part P is doing something completely wrong, then you waste a lot of time to solve that issue. And there, it's important from beginning on to have very good tests, also on an infrastructure level, to be able to cover such failures very early in the process. And then also the lifecycle management. So being able to upgrade from MongoDB version 3.03 to 3.06, for example, and make that seamlessly happen might be shown as easy from a first point of view, but it's not that easy as it looks like, because everyone has different data in it, and you have to make sure that you detect such failures really early. And also here, having very good automated tests are a great help to prove from the beginning on that your lifecycle management is working properly. And also one, for me personally, very important lesson to learn is that from the beginning on, we always should involve all participants and customers. So going from the beginning on to the customer and ask them, how would you like to interact with our system? How should it look like? What are your really requirements? They might have a completely different view than you think they have. That's also what we had to learn. And last but not least, automate everything. Also on this layer of the infrastructure, try really from beginning on not do things manually and download and install things manually in your VMs. From beginning on, use your Puppet modules, use proper hero data, generate them automatically, use your Jenkins jobs to have a way that you always can see what exactly you have done. Yeah, that's already it so far. Are there any questions from your side?
I've heard a lot of experience on OpenStack so far, and yours seems the only one neutral. Are you sure?
Yeah, I might have also took that in the lessons learned. Yeah, we're currently running OpenStack Juno, and we have Red Hat as provider. And honestly, we had really some problems with Cinder and Nova, with inconsistency state and all that weird stuff that you don't want to see, and some really weird race conditions. But with the help of having a vendor behind that thing and having really that engineers also who built that stuff on hold and help us bringing that back up in a good and in a healthy state was key to success there, yes. But it was not everything just running smoothly, that's correct. Okay.
So I have a question here. What would you say the most challenging stateful application that you've tried with this actual model has been?
So far, what we are currently looking at is, so what we currently offer is we offer t-shirt sizes, meaning small, medium, large plans for single host services. And one service that we are currently working on and also providing a beta phase for some customer is Elasticsearch log/Kibana. And having then these 3 containers linked together and like seeing, hey, is now Elasticsearch running so that I can start up Logstash properly and include that error resilience is very hard than rather just having a single MongoDB spinner. And this will also come up on the RabbitMQ cluster that we are working on, having there these distributed containers talking to each other and see which one is now healthy, which can I talk to. This is like the most challenging part in terms of services, I would say. Yeah, we are ready for lunch.
I was about to say, well, at this point, we can adjourn for lunch. Lukas, thank you so
Brian.
much.